So in the previous session, we have discussed about the general methods of preparation, okay, of haloalkanes. So the methods, different methods we have discussed. So the first we had discussed it from alcohol. So these were the different named reactions. Okay, so we have seen the Groves process. So important Groves process. Then we have seen Darcy's process. Okay, can anyone tell me what is Lucas reagent? Yes. Can anyone tell me what is Lucas reagent? What is Lucas reagent? Yes, so this we have discussed in the previous session. Yes. So what do you mean by Lucas reagent?
Which consists of HCl plus anhydrous zinc chloride.
Yes, good. So Lucas reagent. So remember this reagent, Lucas reagent. Okay. So Lucas reagent, it is concentrated HCl plus anhydrous ZnCl2. Anhydrous means what? Anhydrous means there is no water molecule is not associated. Okay, anhydrous. Water is not associated. Okay, with this compound. So anhydrous ZnCl2, zinc chloride. Okay, so then we have discussed about what is Groves process. Then we have seen what is Darson's process. So very important. So why we are using Darson's process for preparation of alkyl halides? Because the byproducts obtained is what? Are gases. Okay, SO2 and HCl. So these are gases. So we can obtain the alkyl halide, okay, in a proper yield. So we are using Darson's process. So in Darson's process, what is the reagent which we are using? Pyridine and thionyl chloride. Okay, pyridine and thionyl chloride. So these we have discussed. Then we had also started with alkenes, that is free radical halogenation of alkenes. Okay, so we have discussed this also. What is the free radical halogenation of alkanes? Then we had started with addition of hydrogen halide, okay, on alkene. So we have seen if it is a symmetrical alkene, so on the what it on the double bond, okay, of either of the carbon on the double bond. So your one on one carbon hydrogen will be added, another carbon your this will be added. What? Bromide ion will be added across the double bond. Okay, if you have a double bond. So when you are adding HBr and you have a symmetrical alkene. Now, in case of unsymmetrical alkene, what happens? So that time the problem will arise. So that time what we are going to use? We are going to use what? We are going to use a Markovnikov rule. Okay, so what does Markovnikov rule states? Yes, what does Markovnikov rule states? Yes. So whenever you have an unsymmetrical alkene, so the addition of hydrogen halide across the double bond takes place in such a way that negative part will be added to the carbon with least number of hydrogen atoms, and hydrogen will be added to the carbon with more number of hydrogen atoms. Okay, so this is a what Markovnikov rule. Now, what do you mean by anti-Markovnikov rule? Anti-Markovnikov rule means what? Anti-Markovnikov rule, it will be reverse of Markovnikov rule. Okay. So this will occur in the presence of peroxide. So suppose, you have to apply this. Okay. Now suppose one reaction is given CH3, CH2, CH bond CH2. Okay. Suppose one reaction is given. Now this will follow
Ma'am,
what?
once again tell me the anti-Markovnikov rule.
Okay, anti-Markovnikov rule is reverse of Markovnikov rule. Okay, now what is Markovnikov rule? Markovnikov rule is what? Markovnikov's. Okay, so if you have a hydrogen halide, negative part, this is a negative part, right? And this is a positive part, that is a hydrogen. So negative part will be added to the carbon, okay, across the double bond of the carbon, which is having least hydrogen atoms, okay,
Yes,
and
ma'am.
positive part will be added to the carbon with more number of hydrogen atoms. Now, Anti means what? Okay, anti-Markovnikov means what? It will be reverse. Means what? Negative part will be added to the carbon with more hydrogen atoms. Okay,
Yes,
and
ma'am.
a positive part will be added to the carbon with least
Least hydrogen.
number of hydrogen atoms. Okay, like this. Now here, how this anti-Markovnikov, now how you will identify which is anti-Markovnikov and Markovnikov. Now, if I give you this reaction, okay, I have given you this reaction. Now, that is 1-butene. Okay, 1-butene. So, how you will, what is this? Is it a Markovnikov or anti-Markovnikov? What it will follow? On the arrow, I have written nothing. Okay, on the arrow, I have written nothing. So, this follows what? This will follow Markovnikov rule. Okay, this will follow Markovnikov rule. So if on the arrow, if there is nothing, if there is no any reagent is written there, okay, so then it will follow what? Markovnikov rule. Then what will be the product? Yes, what will be the product? So CH3, CH2, so CHBr and CH3, right? So this is the major product. Now suppose I'll write there here. Okay. So suppose I have this reaction now. Mhm. Okay. Now what it will follow?
Anti-Markovnikov rule.
Yes. So whenever you have peroxides, okay, any peroxide, sodium peroxide, hydrogen peroxide, or benzyl peroxide, it will follow anti-Markovnikov rule. So what will be the major product? It will be CH3, CH2, 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 CH, sorry, this is CH2, okay, CH2Br. Okay, so this will be the major product. So negative part will be added to the carbon with more number of hydrogen atoms. Okay, and the hydrogen will be added to the carbon with least number of hydrogen atom. Is it clear? Markovnikov and anti-Markovnikov rule.
Yes, ma'am.
Okay. Okay, fine. So we'll move for the next one. So next is addition of halogens. Okay, halogens means what? Halogens means X2. Okay. So addition of halogens. So now what will happen? How you will add the halogens? Now I have a triple bond here. You can see I have a triple bond. So that is carbon, triple bond, carbon. So I am adding a molecule of this what halogen. Okay. Now what is happening? One of the bond will break, and what will happen? It will form X will be added. Okay, so this is the addition. Now, again, one mole of hydrogen I am adding. Okay, one more molecule. Then what will happen? Again, this bond also will break. And what will happen? Then again, one X will be added. One halide will be added. So X can be your any halogen, that is Cl2 or Br2. Okay. Now, again, the examples is also given. So this is one example. So CH3, C, triple bond, CH. Okay, giving you in the presence of Br2. So first one bond will be taken, CH3, CBr, double bond, CHBr. Then one more molecule of Br2, what it will form? CH3. Okay, rest all will remain the same. Only what will happen? Across the bond. Okay, across the bond only this will takes place. What? The this will this bond only will get cleaved. Okay, so one bond. So rest all things will remain same. So across the double bond, addition of halogen takes place. Now, I'll give you one example. Okay, I want to answer from you all. So this plus Cl2 in the presence of CCl4. Okay, tell me the answer. What will be the answer? I'm adding halogen across the double bond.
CH2.
Mhm. Is it?
Yes, ma'am.
Yes. So what is the name? Can you give the name?
Dibromoethane.
Yes, 1, 2, dibromo. Okay, at 1 and 2 position. 1, 2. Sorry, we have taken what? Cl. Okay, this will be Cl then. Because our this is Cl. So it is Cl, Cl. So it is
1 to
1, 2
dichloro.
chloro, 1, 2
Ethane.
dichloroethane. Okay. Okay, now here. What I was talking about. So we have discussed last time. Okay, if the halogens are present on the adjacent carbon, then what they are called as? What they are termed as? If the halogens are present on the adjacent means side to side carbon. Yes, correct. Good. So it is vicinal halides. Okay, so they are called as vicinal halides, vicinal dihalides because there are two. Yes, Siddiqui is correct. Yes, it is a vicinal dihalides. Okay, fine. We'll move for the next one. Now, suppose I give you some more example. Okay, I'll give you one example, then we'll go for the next one. Now here, yes. Okay, what will be the product? What will be the product? So this is a double bond. So the molecule will remain the same. Okay, rest all molecule will remain the same. Only the changes will be at the double bond. Now how the addition will takes place? So at one carbon, okay. So this is a carbon. So C, H at one carbon Br will takes place, add up, and another carbon C, H, H, H. Okay, CH3. So how this is following? What is this rule? Yes. So Br will be added to the carbon having more number of hydrogens, right? So here because there is a bigger group. So Br will be added here. Okay. So this is following what? This is following Markovnikov rule. Another, okay. Now you give the answer for this. CH2, CH double bond, CH2 plus H. Br in the presence of peroxide. Give me the answer for this. What will be the answer? Hydrogen peroxide. So negative part will be added to the carbon with
More hydrogen atom.
more hydrogen atoms. Okay. So what will be the product? The product of green will be CH2, CH. Okay, then here your hydrogen will be added, CH2 and Br. Okay, so this is the answer. Yes, CH2, 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 Br. Yes, good. Okay, so this is the way the addition of halogen takes place. So next we are going to see halogen exchange method. Okay, these are again very important two name reactions. Please mark it important. Finkelstein reaction and Schwarz reaction. Okay, so these are very important name reaction asked for 2 marks. So how it is asked? Explain Finkelstein reaction with an example. Okay, explain Finkelstein reaction with an example, or explain Schwarz reaction with an example, or write the general reaction like that. Now, what is this Finkelstein reaction? So in Finkelstein reaction, you can prepare iodoalkanes. What you can prepare? You can prepare iodoalkanes or alkyl iodides. You can prepare iodoalkanes or alkyl iodides. Okay. So alkyl chlorides. So what will be your starting product? Either you can take alkyl chloride or you can take alkyl bromide. Okay. Alkyl chloride or alkyl bromide, it is reacted with sodium iodide. Okay, sodium iodide. Okay, in the presence of what? In the presence of dry acetone. So dry acetone, and what it will form? It will form alkyl halide. So this reaction is known as Finkelstein reaction. This reaction is called as what? Finkelstein reaction. So Rx plus NaI. So Rx can be your X can be your Cl or Br. Okay, starting product. When it reacts with sodium iodide, what you will get? You will get iodoalkanes plus NaX. Okay, so iodoalkanes are best prepared from Finkelstein reaction. Okay, from Finkelstein reaction, iodoalkanes are prepared. So let me take the alkyl as ethyl. Okay, CH3, CH2, Cl plus NaI. Okay, NaI in the presence of acetone. Okay, what will be the product? What will be the product obtained, students?
CH3, CH2I
Okay,
plus
plus
NaCl.
yes, good. Okay, so how the reaction will take place here? CH3, CH2 will get combined with I. Okay. And what is left with Na and Cl? So NaCl will get combined. So like this is a Finkelstein reaction. So you have to write the explanation and you have to explain it with the example. Very important. Okay. Next is a Schwarz reaction. Next is what? Next is Schwarz reaction. Now what is Schwarz reaction? So in Schwarz reaction, you can prepare what? You can prepare fluorides. Okay, in this you can prepare fluorides. Okay, alkyl fluorides can be prepared. So alkyl fluorides can be prepared from Schwarz reaction. Okay, so what you can do? Alkyl chloride. So the starting product can be alkyl chloride or bromide. So alkyl chloride or bromide is reacted with what? It is reacted with metallic fluorides. Okay, so metallic fluorides. So there are different metallic fluorides you can take, like HgCl2, Hg2F2, then CO, cobalt. Okay, cobalt fluoride, mercurous fluoride. Okay, tin fluoride. So these are the different reagents which are used for as a metallic fluorides. So metals are associated with the fluoride. So here we have taken the silver fluoride. Okay, Ag. Ag fluoride. That is AgF. So what you will obtain? Then you will get RF plus AgX. Okay, AgX. So this is the Schwarz reaction. So let me take an example. So if I take CH3 and I'll take Br. Okay, plus AgF. Then what you will get? So this is a methyl bromide. Methyl bromide. So what you will obtain here? What will be the product?
Methyl chloride.
Methyl CH3 fluoride plus Ag.
Bromide.
Okay, that is silver bromide. Okay. So how the combination will take place? So CH3 will get with this and AgBr. Okay, so methyl fluoride is formed. What is formed? Methyl fluoride is formed. So this is the Schwarz reaction. So mark this as very, very important. Okay, Group's process, then Darzel's process, Schwarz reaction, what is Lucas reagent? Okay, so these are the very important reactions. So whatever I am telling you, please mark then and there itself. Okay, what are important? Because for exam point of view, so these are mostly asked. Okay, fine. So we'll go for the next one.
Ma'am, catalyst or constant, ma'am, or different, ma'am?
For this
Franklin.
is for Finkelstein reaction. What you can see, yes, it is a this is only used. Okay, for name reaction, whenever we are giving now, for example, when we are using anti-Markovnikov rule. Okay, anti-Markovnikov rule will be applied only when you have an unsymmetrical alkene and it is reacted with the alkyl halide in the presence of peroxide. Okay, there should be presence of peroxides only. So if peroxide is there, then only it will follow anti-Markovnikov rule. Same way, whenever such name reactions are there, okay, name
Yes, ma'am.
reactions like Finkelstein reaction, Schwarz reaction. Now in Darzin's process, okay, in Darzin's process, what we have seen in Darzin's process. So in the Darzin's process, we have a alcohol. Okay, it is reacting with thionyl chloride in the presence of pyridine. Okay, and what you will get? You will get Rx, that is RCl plus SO2 gas and HCl gas. So this is constant. Okay, so this only will occur. Only your alkyl will change. Your alkyl, depending upon the example, what alkyl you are taking, what alcohol you are taking, based on that, your product will change. But the reagent will remain the same. Finkelstein reaction, Schwarz reaction. Okay, so these are constant. It is same. Okay. So next we are going to see is the general methods of preparation of haloarenes. Okay, general methods of preparation of haloarenes or aryl halides So first is by halogenation of aromatic compounds. First is by halogenation of aromatic compound, then by side chain halogenation, then by benzene, diazonium salt, and from phenol. So these are the main methods of preparation of haloarenes. Haloarenes means ARX. Okay, they are associated with a aromatic ring. Your halogen atom is associated with a aromatic ring. Okay, so this is the first one by halogenation of aromatic hydrocarbon. So how you can do? So you have taken a benzene. What you have taken? You have taken a benzene. Then you have reacted with what? You have reacted it with chlorine. Okay, Cl2. Then in the presence of FeCl3 and in dark condition. So this reaction is taking place in dark place. Okay, at a dark condition. So these are the conditions, and at a temperature of 310 to 320 Kelvin, you will obtain what? You will obtain chlorobenzene. You will obtain chlorobenzene, and HCl is the byproduct. So this is a halogenation. So how we do halogenation? By reacting the chlorine in the presence of FeCl3 in the dark condition at these temperature. Okay, you will get chlorobenzene plus HCl. So this is the what? This is the halogenation reaction. Okay, now here you can do this substitution with iodine also. So if I take benzene, okay, if I take benzene, okay, and so, but this is very, and if I react it with iodine, so this is a reversible reaction. So so this is what? This is a electrophilic substitution reaction. Okay, so these are the electrophilic substitution reaction. So electrophilic substitution of these arenes, okay, with iodine is very difficult because the reaction is reversible. The reaction is reversible and it requires a very strong reagent. So what can be the strong oxidizing agents which can be used is HNO3, okay, in the and hydrogen periodate. Okay, so these are the reagents which can be used for the preparation of iodobenzene. But this is a reversible reaction, okay, because okay, it is very difficult to get. So this is a reversible reaction. So these are the condition. And by this method, okay, fluoroarenes cannot be prepared. Fluoroarenes, okay, fluoroarenes. So this is fluoroarene. So this is fluoroarenes cannot be prepared by this method because of reactivity. So fluoroarenes are having high reactivity. So it reacts highly. Okay, so because of high reactivity of fluorine, it will not undergo halogenation. Okay, so this is the reaction. Then by side chain halogenation. Okay, by side chain halogenation. So the halogenation of the side chain arenes, it will takes place in the presence of sunlight. Sunlight is nothing but your UV light. Okay, and and it will takes place as this benzylic carbon. Now what is benzylic carbon? A benzylic halide. So halogen attached to a carbon which is sp3 hybridized next to a aromatic ring. Okay, so this is what? This is a benzylic halide, right? Now here, what will happen when we are doing side chain halogenation? The halogenation takes place at this benzylic carbon. Okay, and this side chain halogenation, it undergoes in the presence of UV light. Okay, so how the reaction takes place? See, CH3, okay, plus Cl2 in the presence of 373 Kelvin. So this is a condition 383 Kelvin. And in the presence of light, that is UV light, what will happen? One of the hydrogen, okay, that is CH2H. So this H is replaced by what? Cl. And what is the product form? CH2Cl. Again, when you react it with Cl2 in the presence of UV light, what will happen? Okay, CH2 is there, right? So again, CH2 and Cl. So again, one of the hydrogen is replaced by Cl. So what will obtain? CH, Cl, and Cl. Now again, what is happening? Again, if you react it with Cl2 in the presence of UV light, again one hydrogen is there. So this hydrogen is also replaced by chlorine. Okay, so this is the reaction. So what is formed? CCl3. Okay, so it is benzo trichloride. What is formed? Benzo trichloride is formed. So this way, what is formed? This is a side chain halogenation. Side chain means what? This is a side chain, right? It is not on the this. So what is happening? Your side chains. Okay, so we are doing halogenation on the side chain and not on the aromatic ring. So this is a side chain halogenation reaction. Next, we are going to discuss about benzene diazonium salt. Now, what do you mean by benzene? In this, there is. What do you mean by reduction? Yes, we are not reducing there. Okay. What is happening here? One of the, at each step, what you can see, the hydrogen atom is replaced by chlorine. Okay. We have seen the free radical mechanism, right? Same way, this is a side chain halogenation. On the side chain, we are doing halogenation. At each step, okay, when we are providing, so what is happening here? Due to free radical, the hydrogen atoms are replaced by the chlorine atoms. Okay. And so subsequently, how many hydrogen atoms are there and how much you are providing the UV light and the halogens. Okay. That is in the presence of Cl2. How much you are supplying. So like that, subsequently, the hydrogens are getting replaced at each step. Okay. So this is a side chain halogenation. So reduction, yes, when we are talking about reduction here, so reduction is nothing but we are addition of hydrogen. Okay, but here we are removing hydrogen at each step. Okay, so it is not undergoing reduction. Reduction means only addition of hydrogen. Okay, but at the each step, what is happening? We are replacing the hydrogens by your chlorine atoms. Fine. So next is from benzene diazonium salt. Now, what do you mean by benzene diazonium salt? Now, benzene. Okay. Benzene, or you can take aniline. So this is a aniline. Okay, NH2. This is aniline. So when you have a amine, okay, amine groups attached to a benzene ring, it is termed as aniline. So when this aniline, when it is treated with sodium nitrate, okay, for your information, I'm telling you how this comes. So this is BDC, okay, benzene diazonium chloride, benzene diazonium chloride, BDC, okay. So here aniline, when it is treated with sodium nitrate and concentrated HCl, what is produced? HNO2 is produced. Okay, HNO2 is produced. That is called as nitrous acid. What it is called as? Nitrous acid. So this is sodium nitrate. NaNO2 is sodium nitrate plus concentrated HCl. So when these two reacts, what is formed? Nitrous acid is formed. That is HNO2 is formed in the presence of 0 to 5 degrees Celsius. Okay, if you apply these conditions. Okay, if you apply this condition, okay, if you apply this condition, what you will get? You will get N triple bond N plus Cl minus. So this is your BDC, that is benzene diazonium chloride. Okay. So this is so write the steps. So how do you get benzene diazonium chloride? Aniline, when you treat it with sodium nitrate. Sodium nitrate in the presence of what? Sodium nitrate. I'll write the names. Sodium nitrate. Okay, in the presence of concentrated HCl, that is hydrochloric acid, what reagent is obtained? HNO2 is obtained. HNO2 is obtained. That is called as what? Nitrous acid. Okay, and what is produced? What is the product obtained? It is a benzene diazonium chloride. Okay, now on this benzene diazonium chloride, we are going to do various reaction. Okay, now, when you take this benzene diazonium chloride, okay, when you take this benzene diazonium chloride and you treat it with cuprous chloride, okay, what this is a cuprous chloride, CuCl. What it is? CuCl. So if you treat it with CuCl in the presence of HCl, what you will get? What you will get? Your benzene, okay, that is C6H5. C6H5. So your N2Cl will be replaced by what? Cl plus N2. Okay. And again, same way, if I want a bromobenzene. So this is what? What is the name? This is a chlorobenzene. Now suppose I want bromobenzene, then what I have to take? I have to take cuprous bromide. What I'll take? Cuprous bromide. That is CuBr. Okay. In the presence of HBr. In the presence of HBr. Okay, what you will get? You will get bromobenzene. What you will get? You will get bromobenzene. Okay, now this are called as what? It mark this important Sandmeyer's reaction. What it is called as Sandmeyer's reaction. Very important for 2 marks. Very important for 2 marks. I hope you are marking down the things. Okay, so this is a very important reaction. So they will not ask you how the nitrous this is formed. What BDC is formed. But for your information, I have told you how the benzene diazonium chloride is formed. Okay, benzene diazonium salt or benzene diazonium chloride is formed. So by taking benzene diazonium chloride, we can do the various reaction. So if you treat it with cuprous chloride in the presence of HCl, you will get chlorobenzene plus N2 gas is escaped out, liberated. And if you take cuprous bromide and HBr, you will get bromobenzene plus N2. Is it clear? Yes? Okay. So we'll go for the next one. So this is a Sandmeyer's reaction, important for 2 marks. Okay, we'll move for the next one now. Now similarly, okay, similarly, if you have Gattermann reaction is Gattermann is not there for you. Okay. So Gattermann, I'll just see in the text. So now first we'll see the last one. Okay, with Ki. With Ki, just see with Ki. So when you treat the benzene diazonium chloride, if you treat benzene diazonium chloride in the presence of heat, if you heat this, okay, so what will happen? The replacement. So what is happening? The diazonium group by iodine, okay, it does not require cuprous halide. So whenever you want to do iodide, okay, you want to prepare iodides, that is that is iodobenzene, okay. So that time you does not require any cuprous iodide, okay, but it can easily be done. So there is no requirement of this cuprous iodide. So how we have taken here cuprous chloride, cuprous bromide, like that, there is no required of cuprous iodide. So it can be easily done by heating it with Ki. So if you heat your benzene diazonium chloride with Ki, that is potassium iodide, okay, you will get iodobenzene and N2 gases liberated. Okay, N2 gases liberated. So this is not there for you. Okay, Gattermann reaction and your this one reaction is not there. Okay, so leave this two. So just concentrate on this one. Okay, if I want to prepare chlorobenzene, then I have to take cuprous chloride in the presence of HCl. If I want bromobenzene, then what I have to take cuprous bromide in the presence of HPr. Okay, and I have to treat it with BDC. Okay, benzene diazonium chloride. This is a Sandmeyer's reaction. Important. Then these two are not there. Then directly the last one. So if I want to prepare iodobenzene, so iodobenzene, for in case of iodobenzene, there is no requirement of cuprous salts, because if you heat this easily with Ki, it will be replaced. So this is the reaction. Okay. Okay, fine. So this is also suppose. So here phenol. Okay, we have taken phenol. Then we have treated it with what? Phosphorus pentachloride. Okay, phosphorus pentachloride. What we are obtaining? So your this what? Hydroxy group, OH group is replaced by your chloro group. Okay, chloro group, and you get what? You will obtain the chlorobenzene plus HCl plus POCl3. So from phenol also you can obtain the alkyl aryl halides. Okay, so these are the reactions. Okay, so I'll give you some of the reactions. So you tell me the answers now. So based on what all things we have seen, name reactions. So S plus SOCl2. Okay, what will be the product? Yes, what will be the product? Fast.
C6H5.
What happened? See, till now, what all we have studied the name reactions. Okay. Based on that, you apply and you tell me. So first one, second, fourth, and fifth. Okay. So let me start with the first one. Okay. So here, when you have a OH, so this is a alcohol, right? OH substituted, and you have a thionyl fluoride. So what it will form? It will form a chloro substituted product. So this will follow what? Chlorocyclohexane. Okay, chlorocyclohexane. So this is a Darzon's reaction. Yes, it is a Darzon's reaction. Okay. It is not C6H5. It is not a benzene ring. It is a cyclohexane. Okay, it is a cyclohexane. It is not a benzene ring. So this is your C6H5. Okay, this is your what? This will be your C6H12 cyclohexane. Okay, fine. So now your next one. So this will follow Darzon's reaction, the first one. Now, second reaction, when you treat it with HCl, okay. Now here, one is a benzylic alcohol, okay. One is a benzylic carbon and another is a phenolic OH. Now what will happen? This is a parent chain, okay. So we are not going to disturb this benzylic OH. So here your OH will be replaced. So restol will remain the same. So it will be OH here. This will be CH2Cl. Okay, so this is the product. Now, next one, Br. Okay, Br in the presence of heat or light. What will happen? At the, where the this will form. So here, Okay, at this carbon, it will attack. Okay, so it will be NO2, rest all will remain the same. So CH, Br and CH3. Okay, so this is the product. So substitution will take place at the benzylic carbon. Substitution will take place at benzylic carbon. Okay, now your HI is there. HI is what? It is a hydrogen halide and there is a unsymmetrical alkene. So apply the Markovnikov rule. Apply the Markovnikov rule. With will it undergo Markovnikov rule? Yes. Yes, it will undergo Markovnikov rule. Now, how you will apply? Just see. Now here you see. So this is having CH3, and here there is no carbon. So if I remove this bond, so this what iodide. Okay, where it will attack? It will attack to the carbon having more number of this what hydrogen atoms, and the next year will be least. So here this is the product. So this addition, how the addition will take place? Addition will take place according to Markovnikov rule. So this is the product octet. Now here, so Br2. So here the substitution will take place on the basis of the allylic carbon. So this is a allylic carbon. Okay. So where the addition takes place? Here. Okay. So what is allylic carbon? Substitution of allylic carbon in the presence of UV light. So this is a Br. So Br is attached to the carbon, which is sp3 hybridized, which is next to a carbon-carbon double bond. So the substitution takes place at a allylic carbon. Okay, so these were the methods of preparation of haloarenes. Next, we are going to see the physical properties of haloalkanes. So, what will happen to the physical state and odor? Okay, physical state means what? How they appear, whether it is a liquid, solid, or a gaseous, like that. So, lower members of alkyl halides. Whenever we are discussing about alkyl halides, the lower members, okay, like the methyl chlorides, methyl bromide, ethyl chloride, okay, and some other methanes, okay. So these are all colorless gases. So lower members of this alkyl halide, these are colorless gases at room temperature. Then when you go little higher, okay, the higher members are little liquids. First, they are gaseous, the lower members are gaseous, then the higher members are bit liquids, and as you go further, then they will be solids. So some of the members are solids. Okay. Now, this is about the physical state. Now, when we are discussing about boiling point and melting point, so as you know, these organic halogen compounds. Okay, so these are what? These are a polar compound. Now, what do you mean by polar? You know now. Polar means what? The difference arises due to the presence of electronegativity. So, due to the high polarity, so as you know, so these are the haloalkanes, right? So, because of the presence of halogen compounds, okay, you can see there is a high polarity. And what will happen to the molecular mass? Okay, molecular mass of this halogens are also more. So as you go from a lower carbon to higher, okay, higher alkanes, haloalkanes, okay, not alkanes, haloalkanes, what will happen? The intermolecular forces of attractions become stronger, okay, and their melting point and boiling points are higher. As you go from lower to higher, what will happen? The melting and boiling point will be more and more as compared to the hydrocarbons, because in hydrocarbons only carbon-carbon compounds are present. Now in halocarbons, what are there? Halo compounds, your carbon and a halogen is there. So because of this halogen, there will be increase in the atomic mass also. So iodide, so when you are seeing iodide, okay, iodide is having more weight as compared to bromine, then chloride, and then fluorine. So fluorine is having the least size as compared to the iodide. So iodide is having the more mass as compared to fluoride. So when we are comparing the halogens also, that is halogen compounds, okay, they are having, so the larger molecules, they are having more melting point and boiling point as compared to the lower members of halo compounds. Okay. Then if they are in a straight chain compound, Now, whenever they are straight chain, now CH3Cl, suppose then you have CH3, CH2, CH2Cl. So when you are comparing like this, what will happen? As you go higher and higher, the mass will increase. So boiling point, the interaction, there is strong interaction forces also. So because of that, what will happen? As the molar mass is more and the stronger forces, this compound will have higher melting point and boiling point as compared to this methyl chloride. Okay, so this is with respect to straight chain compound. Now suppose I have CH3, CH2, CH2 and CH3, and I have CH3, CH, CH3, CH3 and CH3. 1, 2, 3, 4, 5. No, let me clean this. Okay. Now what will happen? When you have branch change, yes, when you have branch change, what will happen to the boiling point? Boiling point here, as compared to the boiling point. So these are called as isomers, right? So this is a butane, this is a N-butane, and this is a isobutane. So as you what will happen? Mm, Now when you're comparing these, okay, now there will be substitution of bromide also. Your Cl, here will be Cl. Then if I take one more, okay, that is CH3, CH, CH3, CH2 and Cl. So that time, what will happen here? What will happen to the, as compared to the others, okay, as compared to this, now your N-alkane. So the boiling point will be highest, okay, as compared to here, this will be suppose 346 and this will be 364. So like this. So what will happen to the boiling point? The boiling point will go on decreasing, okay, the boiling point will go on decreasing. By because of increasing branching. As the branching increases, what will happen to boiling point? Boiling point will decrease. Okay, boiling point will decrease. So this is the about boiling point and melting point. Okay. Okay, fine. Then we have to discuss about boiling point, melting point over physical state over. Then is the density. Okay, then we'll see the density. So what about density here? So density, so your bromo, ido, and other derivatives of hydrocarbons, okay, as compared to water, they are very heavy. So what will happen to density? Density will increase with the increase in number of carbon atoms, halogen atoms, and atomic mass of halogen atom. So as compared to the hydrogen carbons, okay, haloalkanes, okay, they are having comparatively more density, because density will increase with the increase in number of carbon atoms. So if you are comparing iodo, okay, methyl iodide will be having more density as compared to that of the ethyl iodide and then to the propyl iodide. So so methyl is having more as compared to that of ethyl and then of propyl. So like this. So then you can see this for the same alkyl group. So iodo, because iodine is having the most atomic size. Okay, so because of that, iodo compounds, iodoalkanes will have more density as compared to the other compounds. Okay, so this is about density. Then solubility. So these haloalkanes, they are strictly soluble in water, but they can be easily dissolved in organic solvent also. So these can easily dissolve in organic solvent. The insolubility in water, okay, it is due to no hydrogen bond formation with water. So this is about solubility. So haloalkanes, though they are polar in nature because of presence of a electronegative atom, but they are insoluble in water. Why they are insoluble? So what is the condition why they are insoluble? Because they cannot form the hydrogen bond with water. Okay, so this is the your physical properties. So these are some of the main physical properties which we have seen. Okay, next we are going to start with the chemical reactions or chemical properties of haloalkanes. Okay, next we are going to discuss what chemical properties of haloalkanes. So today we will just see the introduction. Okay, so first we are going to see chemical reaction means what? Chemical properties means how these haloalkanes will react with the other things. Okay, like how they are reactive towards the nucleophilic substitution reaction, how they are good towards the elimination reaction, addition reactions. Okay, so we are going to see the various chemical reaction. Okay, so first we are going to see about nucleophilic substitution reaction. So what do you mean by nucleophilic substitution reaction? So now you know we have seen. Okay, now we have seen that is we have seen the nature of the CX bond, right? We have seen the nature of the CX bond. So this is what? This is a CX bond, or I'll take it as RX bond. Okay, that is a alkyl halide. So in this RX bond, okay, when you see, sorry, if I compare, so okay, so these are the alkyl halides. So in this alkyl halides, okay, we are when we are seeing the CX bond, okay, then this CX bond is what? This is polar. Why it is polar? It is due to the presence of this electronegative halogen atom. So as the atom, that is halogen, is highly electronegative, what it will do? It will tend to pull the electron towards itself. As a result, there will be development of partial negative charge on the halogen and partial positive charge on the carbon. Okay. Now what will happen? This positively charged carbon. This carbon is what? This is positively charged carbon. So this is easily attacked by the nucleophile. So whenever you have any positively charged species, now what do you mean by positively charged species? This is lack of electrons. Okay, it is lack of electrons. So this can be easily attacked. Okay, it can be easily attacked by a nucleophile. Now nucleophile means what? It is electron rich. Yes, it is electron rich. So it is electron rich, and this is electron deficient. What you can say, the other word, electron deficient. Okay. So electron rich, electron deficient. So carbon, whenever you're having a positive charge, it can be easily attacked by someone which is nucleophilic in nature. And what it will do? It will substitute the halogen atom. And what it will do? It will substitute the halogen atom. So these reactions, okay, these reactions, they are called as nucleophilic substitution reaction. Now CX bond is there. Okay, due to the presence of electronegative atom, there is partial negative, partial positive charge. Now what will happen? A nucleophile is there. Nucleophile, okay, it will attack the carbon. So when it is attacking this carbon, what is forming? A new bond is formed. A new bond is formed between what? Between the carbon and the nucleophile. Okay, between the carbon and the nucleophile, what is formed? New bond is formed. So when this new bond is formed, what will happen to the older bond? It will get cleaved. Okay, it will get cleaved. So what will be the reaction? The new reaction will be nucleophile will attack the carbon and plus X minus. Okay, so carbon, as you know, carbon can have 4 hands. Okay, carbon can bond with 4 other atoms. So like this will be the reaction. Is it clear? Yes. So this is a nucleophilic reaction. Nucleophilic means what? The replacement of one atom by another. Nucleophilic substitution. Substitution means what? Replacement of one atom by another. Nucleophilic means what? We are substituting that atom, okay, this atom, by a nucleophile. So we can see we have substituted the halogen atom by a nucleophile. So it is called as nucleophilic substitution reaction. So because of the polar bond, partial negative charge will be applied on the halogen atom and partial positive charge will be present on the carbon atom. Now the nucleophile, okay, which is the electron rich, it will attack the carbon, okay, positively charged carbon from the behind. And what will happen? As a result, a new bond is formed between this nucleophile and carbon, and the older bond between the carbon and the halogen atom is broken, and a new this is formed, product is formed. So this X, okay, this X, as it is highly electronegative in nature and it has a negative charge, it will cleave with by taking a pair of electrons with along with it. Okay, and this is called as a leaving group. Okay, so this is called as a leaving group. So the halide, it will move as a leaving group. So this leaving group will have its pair of electrons along with it. Okay, and whatever the incoming nucleophile is there, whatever this nucleophile is there, it should be stronger. Okay, it should be stronger than your this what leaving group. So the nucleophile should be stronger than the leaving group. Nucleophile should be stronger than the leaving group. So this is the condition for the nucleophilic reaction. Okay. Better the leaving group, faster is the nucleophilic substitution. And your leaving group also should be a better leaving group. It should leave faster. Okay. So that the nucleophilic substitution reaction takes place at a very good speed. So the leaving group ability of halides is iodide is a good leaving group as compared to bromide ion, as compared to Cl minus ion, as compared to fluoride ion. Because iodide, okay, as you go down the group, what will happen to the size? Size will increase, okay. So the bigger the size of the atom, more is its stability. So iodide is a good leaving group as compared to bromide ion, Cl minus and fluoride ions. And what is the order of reactivity of haloalkanes? Ri is greater than Rbr is greater than RCl is greater than RF. Okay. So this is the important things you have to know. Is it clear? Yes. Is it clear about nucleophilic substitution reactions? So the same we are going to discuss in the next class. Okay. Any doubts up to here? One example for nucleophilic leaving group. Okay, there are various leaving group. Okay, nucleophilic. One example for nucleophile. Nucleophile is not a leaving group. Nucleophile is another one word, and leaving group is another word. Okay, nucleophiles. So different nucleophiles like OH minus. Okay, then OH minus will attack. Okay, so this is a nucleophile. So, and what can be your leaving group? Leaving group we can your this what chloride ion, bromide ion, okay, iodide ion. So these are the, so most probably we take only what is that? OH. There is OR minus also. Then we take NH3 minus, okay. Then we have cyano group, CN minus. So these are different nitro group is there. Okay, so there are different nucleophile, but we commonly make use of only OH group. Okay, so we are going to discuss in the next class. So different reagents, the nucleophile substitution and what type of products are obtained. Okay, so these all things, then we are going to discuss the mechanism and all things in the next class. Any doubts? Okay, fine. So just a second. Yes. So first chapter notes have been sent. Okay, solution chapter. Please go through the notes. So did everyone see the notes? Yes. Okay. So the first chapter notes have been sent. Okay. So if you have any doubts regarding that, so you can ask me. Fine. So whatever has been told till today. Okay, so we have seen the methods of preparations, very important. So please go through that, okay? And we'll see the other things, that is nucleophilic substitution reactions, the different chemical reactions in the next class, okay? So I hope you have understood the things, okay? Fine. So I shall end the session here, okay? We'll meet in the next class. Thank you. Uh, Sri Suresh, okay, you have how to learn or study chemistry. What you have to do, you have to just practice, okay? Or especially organic chemistry, you have to keep on practicing the name reaction. You cannot just mug up the things, you have to practice. So if you practice, then only you can get perfect. So if you just thoroughly, if you just see from up, okay, just read it through your eyes, you cannot understand chemistry. So you have to just read and understand the things and practice by writing the reactions, okay? So I hope you all are practicing. So from the day one, just start practicing so that it will be easy for you. Don't get confused. You won't get confused at the end of the year. Okay. So start practicing from day one, because after these also there are many organic chapters. Okay. So after this we have alcohol, phenols and ethers, then aldehyde, ketones, carboxyl acids, amines we have. Okay. So there are different organic chapters which we have. So from the day one, if you start practicing, then it will be good for you. At the end, okay, at the end, if you sit for, if you are thinking that at the end for 2 months I'll be sitting and then I'll practice, no, it will not help you. Okay, so that time we'll get more confused. So from day one itself, whatever are the important things been told, please start reading and please practice it. Okay, I hope it will help you all. Fine. So we'll meet in the next class. Thank you.